Well, crikey, Mick. It's Monday, the 24th of November. I'm recording this at 11:30, and I got to tell you, I've just looked at the skew-ts today for Brisbane, and it's not looking great. This is potentially a dangerous afternoon unfolding across southeast Queensland. Looking at the skew-t, which will be in the following slides, there's what's called a loaded gun sounding, which is a area of warm air trapped over the top of an area of cooler air, which basically prevents convection. Now, as the ground surface heats up during the day, that energy builds up and builds up and builds up because it's trapped beneath that cap, and it eventually explodes upwards. Now, today, looking at the skews, Brisbane and surrounds are sitting beneath an atmosphere that's absolutely loaded with instability. The heated mixed layer CAPE is expected to push upwards towards about 4,500 joules per kilogram, which is really large. There's a lot of moisture. There's a dry slot or hydrolapse up there, which is combined with downdrafts that can basically create extremely large hail. That cap's going to break, and there's more than enough shear to produce rotating supercells today. So when or if those storms ignite this afternoon, they have all the ingredients required to produce giant hail, destructive straight line winds, potentially very strong microbursts with winds over 100 kilometres per hour, and a potential for very, very strong localised microbursts. This really isn't a routine summer storm day, so stay alert, have shelter ready, and keep your warnings close. And now we'll break down exactly why this setup is so volatile. Thanks very much. Stay safe, keep your eye on the bomb, and have a great afternoon.
Looking at this morning's skew-t diagram, we are seeing an atmosphere absolutely loaded with energy. The red temperature line shows a warm and humid surface with temperatures near 29 degrees and dew points at 23 degrees, creating that sticky tropical feel Brisbane knows well. The green dew point line stays close to the temperature through the lower levels, indicating a deep moist layer with over 40 millimetres of precipitable water. But here's what makes this a hail day. Notice how the temperature and dew point lines diverge sharply above 800 hectopascals. This creates what we call a hydrolapse, a layer of dry air in the mid-levels that's critical for hail production. Hailstones grow larger when they can shed moisture and refreeze in these dry layers. The surface-based parcel path shows nearly 3,500 joules per kilogram of CAPE, while the mixed layer gives us about 2,000. Combined with a significant hail parameter of 10, which is off the charts, we have an atmosphere primed for very large hail. There's a weak inversion around 950 hectopascals acting as a temporary lid, but it won't hold for long. The wind barbs show light northerly winds at the surface backing and strengthening with height, giving us over 22 meters per second of deep layer shear, more than enough for rotating supercells. Now let's look at how this atmosphere transforms through the afternoon. On the heated skew-t, we've applied the forecast maximum temperature of 34 degrees to the surface parcel, shown by the orange line. Look at the massive pink shaded area, that's the CAPE, and the heated mixed layer CAPE has jumped to 4,479 joules per kilogram. This is exceptional energy even by global standards. You can see the LCL marked at around 850 hectopascals, roughly 1,400 meters above ground, and the LFC just above that near 800 hectopascals. The inversion that was capping things this morning, marked on the diagram, gets completely overwhelmed once surface heating reaches 34 degrees. Notice how the blue shaded CIN has virtually disappeared, nothing left to hold storms back. The equilibrium level, marked EL on the diagram, sits extremely high near 167 hectopascals, meaning storm tops could punch above 14 kilometers. The supercell composite parameter of 3.8 and significant tornado parameter of 1.7 confirm this is a high-end severe setup. Combined with the DCAPE over 1,500 joules per kilogram supporting destructive downbursts, and mid-level lapse rates favoring hail growth, any supercell that develops will be capable of giant hail and damaging winds. Looking ahead to tomorrow morning, machine learning models suggest CAPE values around 1,200 to 1,600 joules per kilogram with deep layer shear near 13 meters per second. The atmosphere will be recovering from today's activity, but conditions remain favorable for organized multicells if any forcing mechanisms are present. Tornado and severe hail threats appear low for the morning hours. By tomorrow afternoon, ML models forecast surface-based CAPE climbing back toward 2,000 joules per kilogram with shear around 12 meters per second. The significant tornado parameter sits near 0.26, suggesting limited tornado potential, while the supercell composite around 0.5 indicates marginal supercell conditions. Storm mode would likely trend toward organized multicells with possible weak supercells. Hail and wind threats remain low to moderate. The model comparison chart shows interesting spread between the different ML models. GraphCast and Pangu agree well, showing surface-based CAPE near 1900 to 2000 joules per kilogram with deep layer shear around 23 to 25 meters per second. ForecastNet is the outlier, showing much lower values around 700 joules per kilogram. The ensemble mean comes in around 1500 plus or minus nearly 600 joules per kilogram, reflecting this uncertainty. When models disagree this much, it suggests the atmosphere is finely balanced and small changes in initial conditions could lead to very different outcomes. This is why monitoring conditions throughout the day is critical. The hodograph tells a compelling story about storm rotation potential. Starting from the surface with light northerly winds shown in the purple colors, the wind profile curves dramatically as we go up in height. By 6 kilometers, shown in the green and yellow colors, winds have veered to the northeast and strengthened considerably. This gives us 22.8 meters per second of 0 to 6 kilometer bulk shear, which is in the significant severe range. The bunker's right mover vector, marked by the red star labeled RM, sits to the east-southeast, indicating that if supercells develop, they'll track in that general direction. Storm relative helicity values are impressive, with 91 meters squared per second squared in the lowest kilometer and 172 in the lowest 3 kilometers. Combined with the extreme CAPE, this produces a supercell composite parameter of 5.45 and a significant tornado parameter of 2.67. These are exceptionally high values, suggesting if storms develop, supercells with rotation are favored. The atmospheric refractivity profile shows some interesting features for radio propagation. We can see 2 elevated ducting layers marked in orange near 500 to 1,000 meters, along with a broader superfraction layer higher up around 4 to 5,000 meters. These ducting layers are caused by temperature inversions and sharp moisture gradients in the atmosphere. For remote area communications, this means radio signals may propagate unusually far today through these ducting channels, but could also experience signal dropouts as conditions change. These features often intensify ahead of convective activity. To summarize, this is one of the more dangerous storm setups we've seen for Brisbane. The combination of extreme instability near 4,500 joules per kilogram, a significant hail parameter of 10, DCAPE supporting destructive downbursts, and a supercell composite near 4 creates a volatile cocktail. If storms fire this afternoon, expect supercells producing giant hail potentially exceeding 5 centimeters in diameter, destructive wind gusts over 100 kilometers per hour, and a tornado threat that cannot be dismissed. Park your car under cover. Secure outdoor furniture. Have a plan to shelter. Monitor Bureau of Meteorology warnings closely. This analysis is provided by Distant Curve Remote Area Telecommunications. Stay safe out there.